Hello everyone, and thanks for dropping in. Today a little interesting project, I hope. A useful little device we can build in no time, and it is going to be a logic probe. We can find numerous designs and schematics over the web for different types with a couple of transistors using a single transistor or some ICs. In this case, I picked the simplest design to build using one single transistor. I have also found plastic case from an old broken thermometer, the old type, the mercury ones that has been disposed properly, and I'm going to keep the plastic case from that thermometer, and I'm going to drill a couple of holes and hopefully I can fit the logic probe inside here. But what is a logic probe and how to use it? Well, I'm going to put some links here below for you to read and understand that it's just a little device. It is actually a tester that can help us put under test some logic levels on a circuit. That's pretty much what it is. And then you can understand and read more about TTL logic and CMOS design and what are the similarities and what are the differences between those two types of design for circuits, electronic circuits. And what we usually want to detect is signal or voltage more than 2 volts, which is stated as high, and everything below that is stated as low. Now the simplest design I have found is the one that I put on my paper here, and I'm going to skip the green and red light. I'm going to put just one light to indicate the high state of a signal or voltage more than 2 volts. And here we have it. We have a couple of resistors just to drop the voltage in order to light up the LED, and the basic component is one NPN transistor. The signal that comes from the pin as an input to the base of the transistor actually triggers the emitter and the collector to be tied up together. And if those two are tied up together momentarily, the LED comes up, which means that we have more than 2 volts and actually a signal or voltage that is stated as high coming from our circuit that we have put under the test. So pretty much that's what it is. Momentarily, collector and emitter are tied up together. If the signal that comes from the input pin on the base of our transistor is a high signal, so then the LED comes up, and so we know that this is a high signal that comes in, and if this is a low signal, nothing comes up. The LED in this case will remain off, so we know that we have a weak signal or a low signal at this point. Now let's take a look at the materials list. We need one resistor, one transistor. The resistor is already soldered onto the collector of the transistor. Plastic case, my old thermometer's plastic case, a long wire, a couple of long wires, and a couple of crocodile clips, one red, one black, for positive and negative. And we need to drill a hole right here in order to put the pin, which is going to be the input to the transistor circuit, and we can attach the LED and try to squeeze the whole thing, push it into the plastic case and fit it somehow, and then we can start testing the device, looking for signals around some circuits. And so here we have our little do-it-yourself logic probe for your lab. I could have placed a needle instead of this nail as an input point, but it's more steady like this, and I think it looks fine. I tried to push everything and squeeze it in here, the transistor and the resistor have some electric tape to avoid any short circuit in between the contacts, and the lead somehow squeezed and pushed in this little hole, and the rest is the cable that goes on the back of the plastic case to the crocodile clips. You can see here the resistor and the transistor, some tape in between, and the job is done. And then we can close the cap like this, and this battery is not 9 volts, of course it's 4.5, and I'm using this as a test. So I have connected the alligator clips to positive and negative, and now I'm going to just simply try to get the transistor triggered by positive or high, as we usually say, voltage coming from the battery. So at this point I'm going to just get this in contact with the negative pole. Nothing happens, like this, and now getting in contact with the positive, and the LED comes up, which means that the base of the transistor has triggered collector and emitter to be tied up together, and the transistor acts like a switch. And this is exactly what we wanted to do in the first place. And so, as a final test, I do have a spare and faulty ZX Spectrum motherboard around the lab for some experimentation. I have the alligator clips on positive and negative positions on the motherboard, and now I'm going to check the signal on some TTL logic chip, and apparently I can see that at this point we have a high signal right over here. And how can this be useful? Because when we expect to find a high signal somewhere and this signal is low, then this indicates a problem, and we can narrow down our search for faults around the ICs, or it can also be used on huge rounds of wires and many wires, when we want to really and quickly find out which one holds the positive pole and which one is grounded. So in many ways useful. I hope you liked it, and I hope you like this stuff, and do-it-yourself constructions and whatever comes in your mind. It will be soon coming more over this channel, so please do consider subscribing and give us a thumbs up if you like this stuff. And yeah, I'll be catching you soon with another system, some repairs, modifications, mostly over retro computers, and other clever things, hopefully, that can be useful to you, because this is our hobby after all. So again, thank you very much for watching another episode. I can call it a wrap here, has ended, and yeah, with promise, if time permits, I'll be catching you soon with new stuff, new ideas, and new reviews and demos. Thank you very much. Bye.